All right, our next lesson is called Separation of Variables and Homogeneous Equations. We're going to take a look at the first part, that separation of variables portion today, and we'll pick up with the other part next time. So first we're going to talk about what a separable equation is. An equation of a type where we are able to separate all the x variables on one side of the equation and all the y variables on the other side. Everything we've done so far has been separable, right? It's exactly what we were working with in the last section, is that we moved every variable on the left side. Usually it was a y variable, and every variable on the right side, either a t or an x, to be on the right-hand side. Believe it or not all equations, you can't do this with everything, okay? So those are the ones we're starting with, though. All right, so let's take a look at the first one here. We have the square root of x squared minus 16 times y prime equals 11x. You've seen these used before, not quite with this setup, but very similar. So what are we going to do? Somebody tell me the first step. It's not a hard one. Thank you. Okay, so you want me to write the y prime as dy dx. And you already told me the next step too, Janet. What do you want me to do next? Move what over? Yes, but that's not the only thing that we want to move. The square root too, right? Yeah, this piece and this piece, the dy or the dx, and the x squared minus 16 are both going to move over to the right-hand side. All right, so we're going to move both pieces of this to the right-hand side, which means what's going to be left on the left? Dy, that's it. And on the right, I'm going to have the 11, the x. I'm going to have a division by the square root of x squared minus 16, and I'm going to have a dx out here. So we're going to integrate then, right? Okay, so the integral on the left is the easy one. It's y. The integral on the right, however, is not as simple as the ones we have been doing, but it's way simpler than the ones in Chapter 8 that you dealt with in the last 3 or 4 weeks here, right? There's only one thing it could be, right? It's use substitution. I guess technically you could have some arc trig something or other going on, but you don't. This is a use substitution one. So what's u going to be? And then du? 2x dx, which is nearly what we have on top, right? We have an 11x, but that's okay. So we're going to divide this to the other side, and we can write that 2 out in front with the 11 if we'd like, as 11 halves. And then I've got this as, well, it's 1 over u square root, right? Or square root of u. How else can I write that that's a little bit more helpful for integration? Right. U to the negative 1/2. And then the du is going to be replacing the dx and the x that we originally had. All right, so what is the antiderivative then of u to the negative 1/2? Okay, so let's do it a piece at a time. If you use it with the exponents, what do you get? U to the 1/2 over 1/2, right? So times 2, actually, not divided by 2, agreed? Okay, so this is u to the 1/2 divided by 1/2. At some point, you'll probably recognize that that division by that 1/2 and the division by 2 here, those cancel out. So this ends up actually being y equals 11. The u to the 1/2 is square root of u, but u is x squared minus 16. And in the midst of doing all of this, we have to have a plus c on here. Right? Does all that look okay? Yeah, so we can separate that, right? It was a little bit different than the separations we were doing in the last section, but we can separate that. All right, let's try another one. This one actually says to find the particular solution that satisfies the initial condition. What does that mean? What's it asking me to do in this problem? Right. So it's doing the exact same thing that I was supposed to do in the last problem, except that at the very end, I'm going to be able to solve for C, because I've got an initial condition. All right, but it doesn't start out looking the same. This does not look like the last problem. I don't have any square roots. I've got something set equal to 0. X's and Y's are all on the same side. What do you want to do?
Move it all to one side, move all the X's.
We would like to move all the X's to one side. Can we start by moving that natural log? Would that be okay? Okay. So let's do the 2x y prime, and then it will equal the natural log of x squared. Is there a better way to write natural log of x squared?
2 natural log of
Oh,
x.
yeah, I like that better, because then I don't have any chain rules going on, do I? No. All right, so what else would you like to do then? You mentioned moving more than that, Michaela. Did you have something else you'd like to move?
Divide by 2x.
We could divide by the 2x. It actually, we could leave the 2 alone, but because we've got a 2 on the other side, it'll cancel out, won't it?
Mm-hmm.
So that's actually pretty nice. All right, so now I have, can I write that y prime is dy dx? Are you guys good with that?
Mm-hmm.
All right, so I've got dy dx on the left. And let's see, on the right I have ln x over x. Okay, now what? Yeah, I can also move the dx to the right. So this is dy equals ln of x over x dx. And the reality is that you haven't done any calculus yet. With the exception, I guess you could say, of rewriting the y prime as dy dx. Oh, you're ready for some calculus now, right? What are we going to do? Integral. Well, we are going to do u substitution after we write the integral. So let's write the integral. What do you want the u substitution to be?
Natural log.
You bet. We don't have any form, because we haven't gotten to tables yet in theory, right? We don't have any form for what the antiderivative ln of x is going to be. But that's actually really perfectly fine on this problem, because we can take the derivative of it, and it's 1 over x, which takes care of that denominator, isn't it? I've got natural log over x, which is 1 over x times the natural log. So this piece right here is the du that I have. All right? I wrote that dx, sorry. All right, so the left-hand side is the integral. I'll write it one more time, integral of dy. What does the right-hand side become the integral of in terms of u? It's u du. And then I can integrate, right? All right, so what does that become? Y equals u squared over 2 plus c. And u is natural log of x, quantity squared. And do not be tempted to pull that 2 to the front. That would not be correct. Why not? Right. That square does not apply to just x. It applies to the quantity natural log of x, right? That property where we can pull the 2 to the front applies when it's the natural log of x squared. And the x is the only thing being squared. Okay, so a little bit different of a variation, but still we were able to separate them, right? Sure. Okay, one more. These directions are a little bit different. It says, find an equation of the graph that passes through the point that has the given slope.
You don't have to plug in on the other one, because y equals 2. On the particular solution that satisfies the initial condition.
Uh-huh.
So we don't have to do that. I plugged 1. It says y of 1 equals 2. On the other one.
On the other one. Let me move back here. So. Uh-huh.
You have to plug that into the solution.
Oh, we didn't finish. I'm sorry. You're right. Oh, goodness. Let's do that. I don't even think I wrote that on my notes right. Oh, no, I did. I just wasn't paying attention. Thank you, Janet. Yes, you're right. We are going to go back and finish the problem. Y of 1 equals to 2. That was our initial condition that we were supposed to finish. Thank you so much for keeping me on track. So we're going to put the 1 in for x, right? And the 2 in for y. So this is 2 equals the natural log of 1 quantity squared over 2 plus c. All right, so what is the natural log of 1? It is 0. 0 squared divided by 2. So what's c? C is 2. So my particular solution, which was what I was asked to find, is that the natural log of x quantity squared over 2 plus 2. Fantastic. Thank you, Janet. All right. Back to where I jumped to unnecessarily quickly. We're going to find an equation now of a graph that passes through the point and has the given slope. What's this asking me to do? This is the same question as the last one, isn't it? It's just phrased differently. It says it has the given slope, but slope just means derivative. It has this derivative. Okay, fine. I've got a y prime equals. Fine. And I've got a point, which means that at the end, I'm going to end up with finding what the c value is, that last step we just did in the last problem. So this is the same question. All right, so we're going to start out with the dy dx equals y over 2x. Now what? Move the dx, right? We've been in another problem. We also have to move the y on this one. So we end up with 1 over y dy equals 1 over 2x dx. Here's what I want you to remember, and many of you had difficulty, you know who you are, with remembering this on your basic skills quiz, that this is the same as this, right? The reason I bring that to your attention is because when I take that antiderivative, I don't really have to do anything with the 1/2, do I? It's just going to be 1/2. Okay, so on the left-hand side, what's the antiderivative of 1 over y? Natural log of absolute value of y, actually. On the right, the 1/2 is going to stay put, and what's the antiderivative of 1 over x? Good. Natural log absolute value of x. And then what? Plus c, and we'll call it c1 because, as you know, this setup looks familiar. You've seen this before, haven't you? Yep, this was back in 6.2. We're going to use e's now, yeah? Okay. Now, there is one difference to this. I've got a 1/2 in front of the natural log that's on the right-hand side. How's that going to affect things? It is a constant, but it's a constant before the natural log. Like, for instance, notice if I do the e over here, like this, this is what we want to do. On the left-hand side, what do I get? I just get y. But on the right-hand side, I can't apply the e to the natural log and cancel them out because there's a 1/2 in the way. So what do I have to do? No, I can't multiply. There's not anything to multiply. That's right, Jordan. That 1/2 can be brought up to the exponent on the x so that it's not in the way any longer. There's nothing separating the e and the ln. So this 1/2 can become an exponent on the x, which actually becomes, and I'll write it one more step of it, this is e to the ln of what? What? Square root of x, thank you. It's a square root of x. And just for the sake of doing it again, we'll do this. This is then e to the c1, right? Oh, I don't have any more space. All right, well, let's do this. Okay, that gives me more space. All right, so taking this problem then, I've got y equals what? What happens to the e to the ln of square root of x? leaving me with square root of x. What about the e to the c1? That's just c. Can I write that in front of my square root of x? Sure. So this is c square root of x. And that's really friendly when you look at the coordinate pair that we were given, 9, 1, right? Sure is. So if I use this ordered pair that I'm given right here now, what do I put where? 9 goes in for x. 1 for y. So this is 1 equals c times 3. What's c? 1/3. So the particular solution, or the equation of the graph that passes through the point, as the question was asked, is y equals 1/3 square root of x. That solution looks a lot different than the ones we were getting in the last section, which is why I wanted to show it to you. Yes, Kirsten?
Would we get it wrong if we have like plus or minus 3 instead of making it?
That's a good question. So when the square root is in the problem initially, we don't put a plus or a minus on there. And that square root came about because we had that 1/2 value that we made the exponent. So that is sort of understood to be that value already. So it's not needed to put the plus or the minus on there. The minus would simply give us an erroneous possibility.
Okay.
Yeah. Good question. Any other questions? All right.